Hello everyone, today I'm going to show you how I added a car engine sound to my driving game in just about 15 minutes using Leat and Bevy. Leat is my visual node-based programming language. Its goal is to make it possible to create synthesizers for games, or dynamic soundtracks that react to gameplay, etc. It's extremely work in progress at the moment, and is lacking many essential features, but I just reached a point where I can actually use it to make a car engine sound, so I wanted to make a little demo. So the first thing we're going to do is to add the Leat plugins to our game. There's 3 plugins that we are interested in. The first one is the main one, the Leat plugin. The second one is the Leat audio plugin, so that we can actually create entities that emit sound. And the third one is the Leat remote plugin, which will let us connect the editor app onto our game while the game is running. Then I prepared an empty plugin for my engine sound. So it will be responsible for 2 things. The first is attaching the Leat components to newly created engines, and the second one is updating the inputs to the synthesizer, so the axle's rotational frequency and the throttle input. So we're going to start by attaching the components to the engines. For this, I'm going to use an observer. I'm just going to call it add engine sound. And I'm going to add commands to it so that I can add components onto the entity. I'm going to add 3 components. First one is the Leat runner. That's the main one, where you can specify a patch. We don't have one yet. We're going to create it, so for now I'm just using none. And the inputs, that's just the how they would be initialized when the patch starts running, but we don't really care. We're going to set them every frame, so I'm just using empty inputs. The second component is the Leat audio player, where we specify which output of the patch is going to play sound. So we're just going to use the first output. And the third one is the Leat remote serve component, where we can specify the address on which the app will connect. Then the second thing that we need to do is update the inputs to the patch every frame. So I'm just going to use a system for this. Update engine sound inputs. This system will query for all the engines. And the Leat runners. And I'm also going to need the axles, because that's where the angular frequency of the engine axle is stored. So I'm just going to iterate over all the engines. Grab the axle, and the axle has an angular frequency stored in radians per second. I actually want hertz, so I just need to convert it by dividing by tau, or 2 pi, whatever. And then if, in case the engine runs backwards, I would like to keep it at 0. So I'm just going to prevent it from going negative. Now I just need to call setInput on the runner with inputs of type float. And the second one will be the engine's throttle, the throttle input. Now we just add this system in our game. In the update schedule. And that's it. So now I'm just going to start the game and we can start creating the sound. And I'm going to start the editor also. There we go. So I will start by adding all the inputs and outputs to our patch. There are basically 2 inputs and 1 output. So the type of the inputs is float, and they are in the generic ECS driver. And our only output is the audio buffer. So we can just try something real quick. We can put an oscillator here to check that everything's working, which it is. And maybe what we can do is, to get started, control the frequency of this oscillator using the frequency of the engine. For this we're going to need 2 nodes. The first node is going to let us go from the, let me disconnect this, from the context of the generic ECS driver into the audio context. So this is the interpolator. We just specify which driver goes to which. And the second node we are going to need is to convert this float into an audio buffer here, which is this is the frequency input of the oscillator. So we can just use this constant buffer node, which will copy the float to fill the entire buffer. And now if we connect it, when we rev up the engine, we should hear the oscillator. It's changing frequency. It's very low frequency at the moment, but I can push it up so we can hear better. But of course, what we want is an engine sound, not a sine wave. So what we can do is use a little technique where we just play a sample of that sounds sort of like a cylinder explosion of the engine in a loop. So what I'm going to do is I already prepared a couple of samples here. I'm going to create some kind of V8 style engine. So I'll just add 2 samples for like each side of the engine. I'm just going to import them. And we can hear what it sounds like if I just add this here. This is the first sound. And oops. That's the second one. I'm just going to add addition node in order to combine the 2 signals so we can hear them both. And now in order to control them, we're going to add a sequencer, which will let us play those samples in the loop. So I'm going to add 2 outputs to this sequencer, connect them to the samplers, and the frequency of the sequencer is given by a float, so we're just going to use this. Now I can draw some kind of V8 pattern thing in here. And if we rev up the engine, we should hear something that sounds kind of like an engine. Now the frequency is a bit low because, let me disconnect this. Essentially, 1 unit of time will play 1 cell in this sequencer. But in reality, for 1 cycle of the engine, we want to play 4 cylinder explosions. So I'm just going to multiply the engine frequency by 4 using a multiplier node. I'm going to add a knob with a value 4 and connect this up. And now it's better. Now there's one issue with our sound is that we're not really supposed to hear the cylinder explosions when we're not revving up the engine, so when the throttle is not pushed. So we're just going to control the high frequencies of the signal using the throttle input. So what we can do is just add a filter. I'm going to add a high sharp filter, which lets us add gain to the high frequencies. There we go. I need an interpolator for the same reason as before. And we also need this is the gain, and it's a buffer type input. So we are just going to use this. And now if I rev up the engine, we should hear. Yeah, we can only hear the sound when I rev up, when I push the throttle. And that's just because we have to adjust the frequency of the filter here to let it pass some frequencies, some low frequencies, even when we're not pushing the throttle. So maybe this is good. Yeah, that's good enough. One thing we can do is probably tone down a bit those high frequencies using another filter. I'm just going to use a low pass filter this time. Good enough. I'll also add a high pass filter actually, because there's some low frequencies that are a bit annoying. So let's just add this. I think the throttle effect is a bit too strong, so I'm going to reduce it a little bit by multiplying the signal. Yeah, that's pretty good. If you're wondering, the first knob here is the cutoff and the second one is the resonance of the filter. And that's it. Now what we can do, I'm pretty happy with this patch, so I'm just going to save it. And I'm going to export it as well into my game, so that I can import it automatically. So I just put it in my assets folder. And I can stop the game. And now here in the patch, I can actually specify the path to my asset. So I think it was sounds with an S, yeah. Engine.lte. And if I start the game, I can actually also remove the remote component. We don't need it anymore. And I should just hear the engine straight away that we just created. There we go. If you want to find the code for Leat, you can find the Git repository on Codebug. It's all extremely experimental at the moment, so many things are going to change. Many things are still missing, and the performance needs improvement, etc. But I will also post updates on YouTube whenever I reach new milestones or if I have something interesting to showcase. Thanks for watching.